In this assignment, you want to use databases to investigate questions pertaining to your curriculum. There's a wide variety of databases out there. The database that I'm going to illustrate right here is called Gapminder. Now, Gapminder aggregates information, statistics, and so forth from various regions of the world. You can look over here and you can see that all of the yellow dots there represent information from North America and South America. The orange represents Europe and Central Asia, the blue Sub-Saharan Africa. And so it allows you to do an analysis both individually by countries. So for example, you could look at Afghanistan right here, or you could look at let's say Zambia, and it's going to show that where those are. Or you can look at entire trends, like saying, okay, I really want to see, what South Asia looks like. So you can look either individually or in aggregate at particular regions and start to see if there's trends and there's patterns to investigate. And so you're going to be developing a lesson plan that's going to require the students to use a particular database, and again, it's up to you as to which database to choose, to investigate a topic of relevance to your particular curriculum. So, for example, I found one on the internet here by a teacher who is teaching apparently middle school students, and he wants them to understand the concept of gross domestic product. But rather than just giving a lecture on gross domestic product, he's actually having them do research by comparing the gross domestic product per capita on various different countries and different regions of the world. And so he's said that he's going to use Gapminder, and he's defined what the purpose of the lesson is and giving a description of the lesson and stating its objectives. And in this case right here, he's saying, this is going to take about 4 or 5 class periods, but as we go through that, we're going to have the students follow a particular procedure, and they're going to be asking and answering different questions and hopefully finding out a lot about the world and about what the real meaning of per capita means, or gross domestic product per capita, and a lot of other different variables that he's going to have them investigate. Now in this particular assignment, he also has questions that they specifically answer, starting with very basic questions. Can they read the charts? Can they read the diagrams? So for example, which country had the highest GDP per capita in 2007? What was the number? In other words, just trying to get some facts. And then he tries to get them to start to see patterns. So for example, in gross domestic product ranges, that most African countries tend to have GDP capita between blank and blank, and most European countries have it between blank and blank. And so they're going to look at the chart and say, okay, let's look at the income per person expressed as gross domestic product per person, and look at different regions. So the blue regions right here would be the African countries, and you could say, okay, well, how would the students now look at this data and try to get some kind of an average value? Not an easy thing to do, but they can start to look at those blue dots and see how they you can kind of condense them into one location and then try to do an estimate there, or perhaps on the average gross domestic product per capita. Now you could compare that versus, for example, the European nations right here, and you can see that students will see that while they are clustered, the countries in Europe tend to be significantly higher on life expectancy than the countries in Sub-Saharan Africa. So again, on this axis right here is measuring life expectancy, and you're seeing in Sub-Saharan Africa that your life expectancy in a lot of countries is like the high 40s on up to maybe 65 in Madagascar. So but then in terms of per capita income here, we can see some countries like Equatorial Guinea actually have a fairly high income, yet still their life expectancy is around 51, still very, very low. And by comparison, you could look at the European countries and you could say, wow, some of these have very high per capita GDP. Say Luxembourg, where I was last summer traveling through, and it is the wealthiest country per person. In other words, per capita, there's more income generated in that country per person than in any other country on earth. And life expectancy there is also very high. And hopefully they're going to start to see some kind of a pattern here. They're going to start to see that there's an upward trend here, that as the income per person increases, then also the life expectancy increases. In other words, they're putting now their math to use right here. Some of the students might say, well, wait a minute, this doesn't appear to be a traditional scale, and certainly it's not. This is a logarithmic scale. And now you can start to bring in the mathematical concepts here. And if you're teaching again a math curriculum, you can say, well, what's the purpose of understanding a logarithm? Well, there's many purposes for particularly plotting things where there's a wide range of values. If I plotted this in a linear fashion, you can see that the data looks very different. The question is it better to represent the data in a linear or in a log? Well, the log shows the line, and so you can actually see there's some kind of a logarithmic relationship between income per person per capita, GDP, and life expectancy. And they're going to understand that that their math is actually put to use right there in a social studies class. Now, we're plotting here life expectancy as it correlates with income per person. And if we play this versus time, we can see here as time ticks on here, the years being put up on the screen in the background, the countries start to see an increase in life expectancy. In other words, they get higher and higher. The yellow one up here, that one right there is the United States. And also their income per person tends to be increasing. In other words, the trend is to the right and trend is up. In other words, countries tend to be producing more wealth, and then they are also having higher life expectancy. You may notice the big red dot. That's China. Let's just track China back here. We can see that at the beginning of this, back in the 1800, life expectancy in China was about 32. Well, even in the United States, which is a fairly small country, by that time it was only about 39. Obviously there's a lot of infant mortality and accidental deaths and so forth, and not the health care. And hopefully this gets students to start to look now at history. So now we're actually looking at this from a historical perspective. What's changing over time? And we could scrub through this by just manually controlling it as I'm doing right here. Just watch the big red button. Look at how it drops down there. Right there we can see between what's going on there between 1847 down to 1856. We can see the life expectancy drops precipitously and the per capita income drops there. And so now the students say, well, what was going on historically in China? And some might say, well, it happened to be the time when a lot of Chinese came to California to build the railroad and to settle in agriculture and so forth. And is there some kind of correlation between this massive immigration to California and other parts of the world and what you see taking place right here, where there's that big drop between 1846, where the life expectancy is about 32, and the per capita income is about 764, and then when we drop down, you can see that right there at about 1855. Right at about the height of the Chinese immigration here to the United States, the life expectancy has dropped down to 26, where the per capita income is about 400. So what was going on in China during that time? Now that you'd have them in your lesson plan, go and do a research and so forth. Was there famines? Was there floods? Was there revolution and so forth? And now they're actually getting to do some literature search. So they're starting to do their own inquiry as to what possibly could explain this trend. Now, watching the red ball, you'll see it getting very static, whereas the yellow one, which is the United States, is moving ahead very rapidly. Life expectancy already up to 54 by the time of the beginning of beginning of World War I. And so the United States has the highest per capita income and one of the highest life expectancies. But now again, watch the yellow dot and watch the red dot. The red dot's, it drops way down there. Notice right there that their income is dropping, going from here to here, but their life expectancy is getting greater. What was happening during this period? What was happening during the late 40s and so forth, which would cause their income to drop so much? And now, whoa, look at it, it's going up and down. You can see there as you scrub back and forth, look at that huge drop right there. Here's a drop right there on the big red ball from a life expectancy of about 50 in 1957 to life expectancy drops down to 1960, way back here to about 32. So again, students can start to understand what's going on with the communist revolution, collectivization, trying to generate some hypotheses as to how is that affecting the per person income, how is it affecting life expectancy. And again, doing firsthand research himself using the databases that is right in front of them. So as we scrub forward here, all of a sudden China takes off again in the 60s. Its life expectancy increases even though its per capita income doesn't make a whole lot of move forward. And now we can see, like after Nixon visits China, essentially opening China to the West in many ways, China's economy starts to take off and the income starts to increase. That ball is moving pretty rapidly to the right, and life expectancy increasing dramatically as well. So, and again, that story could be investigated for any country on earth. And so, if you have students from Vietnam, well, they could look at Vietnam and they could actually track the history of Vietnam, again, just by looking at this through time and say, what's going on? What happened? If we were to track that, what actually was taking place that would explain these backwards trends here, like in the 70s, did this have any correlation with the Vietnam War? And then, how is it starting to move forward? Is this perhaps related to trade with the West and so forth, and opening of factories and so forth? And so, again, this is a dynamic database, and there's so many things you can investigate with this. You can investigate it in map form right here. So if you were to look at a particular indicator, it'll just kind of show those things on their relative positions on the map. So if I go there and turn off Vietnam, now you can see all of them right there. And again, the size of these, here's the United States, you can see the size of the circle is proportionate to the population of the country, and the location of that dot is obviously going to be in the geographic center of that country. And so students are now learning geography at the same time. In other words, where is China? Okay, well, they can see it right over here. They're seeing the location of China. They see it's a massive circle indicating there's a lot of population here in Southeast Asia, or South Asia and Southeast Asia, when you combine these various different countries, Bangladesh and India and China and so forth. And so they can start to get kind of the concept of graphing information, both pictorially as well as, with your typical XY plots and so forth we saw before. Well, people might think that, well, that's nice, but I don't really care about that particular statistic. Not a problem. You can investigate many different issues. If you're teaching, let's say, an ecology class or environmental science or biology class, where you're talking about ecological issues, you might look at things like energy or the environment, but maybe looking at emissions, like for example, like the CO2 emissions. Okay, if we're looking at, let's say, CO2 emissions as a function of time, or maybe you're looking at CO2 emissions in terms of tons per person. And now we can look at the data right here and we say, well, look at it, it's all down here at the bottom. It doesn't look like too much. We can see, United Arab Emirates, Dubai, wow, they're producing a lot of CO2 per person. But all this wasted space up here, what would happen if we change that plot to a log-log plot, where we're now plotting the logarithm of CO2 emissions per person per time versus the income per person per time, gross domestic product per capita. And now students, again, you're bringing back the math concept. What is a logarithm? How does that allow you to represent widely ranging values and data on a simple graph that fits on a sheet of paper you can put in your textbook or your notebook? So here we're starting to talk again about the value of the math. So we use a simple concept here of a logarithm to basically take these large scales and condense them for plotting purposes. But now from an ecological perspective, we could look at the time sequence right here, and we could say, okay, looking at historical data, what's going on here? What's going on with the United Kingdom? Why is their CO2 production so high? And of course, you can see that they were, of course, the source of the, you might say, the beginning of the Industrial Revolution took place in England. But now, by the turn of the century, the United States has taken the lead in terms of producing the amount of CO2 per person. Wow, what country is jumping way up there? And all these things beg, answers. What's actually going on, and what are the general trends that we see over time? What are the specific trends that for a particular country? How does it trend over time? And you can also have students doing extrapolations. If the CO2 emissions per person are increasing dramatically as the income is going up, then what happens also if at the same time the population is increasing? What does that suggest about the amount of CO2 actually in the atmosphere as a whole? And you can start to get into concepts of climate change and various other issues that are related to greenhouse gases and so forth. And so you could see you could get into an environmental science issue. The point is, a simple database, not a simple database, but a database like this can be used to investigate many, many different types of things. And so your goal is to choose a database of your choice, and be able to develop some kind of a lesson plan that engages the students in research using that database. So I've put a number of them here for you to look at. So if you're looking at the class website under databases and scroll to number 4, you will see here that there's a lot of different databases out there on the web related to many different topics. I'll just show you one more here. This is one of my favorites, called Wolfram Alpha. It's a computational knowledge engine. Okay, this is great for math and science people, but not just that. You'll see other areas as well. Wolfram Alpha basically looks at all of these different sets of data and allows you to compare and contrast things. So for example, if I put in here, how does a lion compare to a tiger? And it's going to give me statistics that it finds in its database. First, taxonomically, we can see, a lion and tiger have essentially the same taxonomy down to the species level. So they have the same genus Panthera, but at the specific level, Leo as a lion and tiger, or tigress I should say, is the tiger. And but they are very similar apart from that in terms of their taxonomy. And you can see that their the maximum recorded lifespan is similar, etc., etc. And so it allows people to do comparisons of various different things. They could compare here maybe Apple stock versus IBM, or maybe just the companies. Okay, how does Apple compare to International Business Machines, IBM? And you can see here that a huge shift that's taken place in recent years, where Apple becoming one of the highest capitalized companies on earth, $541 billion in net worth, versus IBM, which of course was an industry leader for very, very many years. You can start talking about what was it that allowed Apple to catapult to this position of prominence in the field of technology. So now you can relate it to the business world. You can look at databases from a business perspective, and again, bringing in the math. Okay, let's start to look at relative price history between these two, and what could explain now these huge spikes in terms of Apple stock versus IBM stock. And again, the idea with this is you're having them investigate questions, answer questions that they could only answer by looking at the data. And the nice thing is these databases give you information that you wouldn't be able to get in any other way without a tremendous amount of time spent. And so I encourage you to look at Wolfram Alpha. Look at the examples that they have at the top. You'll see that there's a lot of different examples we can look at. If you're trying to look at something from maybe one of the other perspectives, like music, okay? Is there, in terms of songs, what could we find out about, comparing different artists and so forth from a database? So it's up to you as to, the topics you choose, the databases you select to work with, but develop a lesson plan that engages the students in asking some questions and answering some questions pertinent to your curriculum.